Good morning, students. I hope whatever the part I am daily teaching, you are revising, make a practice of IUPAC nomenclature system of coordination compounds. Write your name and your seat number in the chat box. Yes, we will start. Till some students are joining. So till we will do the revision of yesterday's lecture. Yesterday we started the IUPAC nomenclature system of these coordination compounds. So there are some rules. These rules are quite different than the IUPAC nomenclature system of organic compounds like alkanes, then aldehydes, ketones, carboxylic acids, and amines. So this IUPAC nomenclature system is different. In this, there are central metal atom and ligands. So just I will do the quick revision one by one. So first, in the complex, we have to give the name of the ligand first and then the name of the metal ion. Second rule is in case of anionic ligands, if its ligand ends with IDE, for example, if it is chloride, if it is bromide, if it is iodide, we have to take O. It should be ends with O, like chloro, bromo, iodo, like this. And if it ends with ATE, for example, if carbonate is there, the name will be carbonato, like this. What is the rule number 3? I will take the quick revision because yesterday I explained in detail. So name of the complex should be in single word. There should not be any spacing between the name of the ligand and name of the metal ion. Rule number 4 was after the name of the metal, we have to write the oxidation number or its oxidation state in bracket with Roman number. Remember, oxidation state or oxidation number, it should be written always in Roman digits. Then rule number 5 was if in the complex there are more than one type of ligand, then more number of ligands are there. So we have to write di for if there are 2 ligands, we have to add the prefix di. Then if the 3 ligands are there, we have to add the prefix tri. If the 4 ligands are there, tetra, penta, hexa, and so on. Then rule number 6 was for the complex having more than one type of ligands, then we have to arrange alphabetically. So in between, one example I have explained, if the aqua water ligand is there and chlorine ligand is there, so alphabetically A comes first. That's why we have to write this ligand first, aqua, and then chloro. Alphabetically, which comes first, we have to write the name according to that alphabetical order. Then rule number 7 was, if the ligand having the already numerical is there, for example, ethylene diamine. See, in case of ethylene diamine, already di word is there, so we are not going to repeat this di word. So it will, if the 3 ethylene diamine ligands are there, it will be converted into tris. 3 for tris. If the 2 ligands are there, it will be bis, and if the 4 ligands are there, it will be tetrakis, like this. And last rule was, if the metal is cationic or neutral, there is no change in the name of the metal, but the name of the metal will be changed when it is anionic complex. Anionic means when the complex is having negatively charged. Remember, this rule is very important, because many times students get confused in this. Means they didn't understand whether the complex is cationic or anionic. And it is very easy, the complex is cationic or ionic, because we have to check the charge on the complex. If there is a negative charge, it will be anionic, and if the complex is positively charged, it will be cationic complex. So if the complex is cationic or neutral, there is no change in the name of the metal. But if the complex is anionic, we have to change the name of the metal. It should be ends with ATE. Then we all discuss this. These are the anionic ligands, bromide, and this is carbonate. See, carbonate, it ends with ATE. So the name of the ligand in IUPAC, we have to write carbonato, like this. Then these twos are, I specially told you, please concentrate on these 2 ligands. Please give more attention, because these are quite confusing only. SCN is there, it will be thiocyanato, and NCS is there, it will be isothiocyanato. And these are the neutral ligands. These do not having any charge. See, ammonia, then carbon monoxide, water, and this carbonyl, means these ligands, ammonia, then carbon monoxide. Carbon monoxide is in IUPAC, it is called as carbonyl. So these 1, 2, 3, 4, these are the neutral ligands. Remember, there is no any charge. If the anionic ligand is there, there is if the bromine is there, it will be -1. NO3 will be there, it will be -1. But if the SO4 is there, see, because the charges are required for calculating the oxidation number. So this is also explained when the complex is anionic complex, the name of the metal, how the name of the metal changes. The name of the metal, see, if aluminum is there, it will be aluminate. If the cobalt is there, it ends with ATE. This is required when the complex is anionic. And how to identify the complex is anionic? Because the complex contains negative charge. And if the complex contains positive charge, there is no change required in the name of the metal. So we will take the examples. Yes, we are discussing these examples last lecture. So again, I will start from these examples. See the charge on the complex. When complex is given, here already the name anionic complex is given, but for the board exam, they will give only the complex. So we have to identify the charge. See, there is a NiCN4 2 minus. So this Ni is the central metal atom. Now you are very familiar with the coordination compound. Coordination compound contains central metal atom. So this Ni is a central metal atom, and these are the 4 cyanide ligands. These are attached to this nickel. And this square bracket is a coordination sphere. These are very tightly arranged when this is dissolved in water. These do not dissociate, or these do not give ions. So all these part already explained by the Werner theory also. So this NiCN4 2 minus, this is anionic complex. Now how to give the names? So according to the IUPAC nomenclature system and the rules, number 1, so name of the ligand we have to write first. So how many ligands are there? See, 4 number, this 4 indicates there are 4 cyanide ligands. So this the name will be tetra, because according to the IUPAC nomenclature system rules, if there are more than one, we have to add the word, we have to write the words like bi. If the 2 ligands are there, it will be bi. If the 3 ligands are there, it will be tri. If the 3 ligands are there, it will be tri, tetra, like this, penta. So as in this example, there are 4 cyanide ligands. So the name will be tetra first. Tetra, then cyano. Why cyano? Because this is a anionic ligand. See, this is an anionic ligand. So cyanide ends with cyano, and this is a see, the name of the metal is also changed. It instead of nickel, we have to write nickelate. Why nickelate? Because the complex is anionic complex. See, and in the bracket we have to write, after the name of the metal, we have to write the oxidation state of the metal. And already I told you how to calculate the oxidation state. It is also given in these notes also. If you didn't understand, you can call me, I will explain again. But it is very easy. Formula is there. It is the algebraic sum of the it is the algebraic sum of the oxidation state of the metal and oxidation state of the ligand. So we have to see this is 2 minus, so the charge will be 2. Now come to the second example. See, this complex is also anionic complex. So if the complex is anionic, automatically you should think in this name of the metal should be changed. So it will be cobaltate, it will be ferrate. See this B example, it is a cobaltate, it will be ferrate, because the complex is anionic complex. So in detail we will discuss this one. There are 3 oxalato, because this is C2O4, it is oxalate ligand, and 3 indicates tri oxalato. See, it is a tri oxalato and cobaltate. The name of the metal will be changed. Cobaltate 3. In bracket, the oxidation state of the metal is written 3, and it is ion, because these are the negatively charged ions are there. Then number 3, hexa. This 6 indicates hexa cyanoferrate. Now it is hexa cyanoferrate in bracket 2. Oxidation number of the metal Fe is shown here 2. And how to calculate this 2? Already there are 6 cyanide, means this is the 6 minus and this 4. So when these are the 4 minus come to this side, it will be 2. I explained how to calculate the oxidation number. So now we will take the next examples. Compounds containing complex anions and simple cations. So after the see this complex is having the ions are given, already the charge is given, but there is no any charge. So if such type of complexes are given for the examination, then how to identify whether the complex is positively charged or whether the complex is negatively charged? So simple trick I have given to you. When, see, this is Na3, we have to check it whether it is right hand side or left hand side. It is on left hand side. So if this is the left hand side, these are the positively charged counterions. This is sodium is positively charged, potassium is positively charged, this sodium is positively charged. So automatically there will be the negative charge on the complex. So all these complexes are again anionic complexes, means this complex will get the negative charge. So this name, again the name of the metal will be changed, this name of the metal will be changed, and this name of the metal will be changed. So if such type of examples are given for your examination, we have to write the name of this counterion first. We have to write the name of the counterion first. So this is a sodium, you have to write the sodium here. Forget about the number of sodiums. Don't write trisodium here. So this rule is actually not given in UPSC, but we have to remember If there are three sodiums are there, we didn't mention here how many sodiums are there. Only we are writing here sodium. So sodium, it is written sodium. Then come to the ligands. So how many ligands are there? 6. Hexa. 6 indicates it is hexa. Then nitro. This NO2 ligand is nitro, and this is a cobalt. It is converted into cobaltate. And 3. Why it is converted? Because this ligand, this complex is having negatively charged, because this is positively charged. These counter ions are positively charged. We will take the second example, then we will understand. See, what is the second example? K3. This is the coordination sphere. Al C2O4 thrice, means there are 3 oxalate ligands which are joined to the central metal atom is aluminium, and this is the counter ion K3. Counter ion, what is this counter ion? I will explain. This when the complex is dissolved in water, these complex ions only forms the ions, but this is a secondary sphere or coordination sphere remains as it is. And also remember these counter ions, when these are the left hand side, the complex will be negatively charged, anionic. And when there is a right hand side, NeSO4 is there, Cl is there, these are already negatively charged and the complex will be positively charged. Also we will take such type of examples. So I think you understand this example number 1, example number 2. Then I am coming to the example number 3. See, again there is a sodium, so name is written here sodium. Then come to the coordination sphere. 6 indicates hexa. So again it is hexa. Fluorine, it is fluoro, and aluminium, again it is converted into aluminate. In bracket, it's oxidation number of this metal is shown here. See, the oxidation number is 3. Why it is 3? Because 6 fluorine having the 6 minus, and 6 minus and this Na plus 3. It will be 6 minus 3, it will be 3. And come to this oxalato. This is the 3 minus. So the charge will be aluminum having the 3 plus. Then in this nitro, this NO2 is minus, so 6 into minus 1, it will be minus 6, and this 3. So 6 minus 3, again it will be 3. Then I'm coming to the cationic complex. Now in case of cationic complex, the name of the metal will not change. See, the cationic complexes means these are the positively charged complexes. See, this is a 2 plus, here is also 2 plus, there is also 2 plus. So these are the positively charged complexes, remember. So in case of positively charged complexes, the nomenclature method is same, but the name of the metal, see, the name of the metal will not change. It will remain copper as it is. So we will start, this is Cu, NH3, 4 and 2 plus. So tetra stands for, because there are 4 amines are there. So tetra amine, name of the ligand is amine, already I explained. And remember the spelling also, AMMINE. Remember this spelling, many students, because at the time of board exam and paper checking, I know students make difficulty here. So the spelling of amine should be very important. So tetra, why tetra? Because there are 4 ammonia ligands, tetra amine and copper. See, it is not now copperate or cuprate. See, copper remains as it is because the complex is cationic. So most important thing in case of IUPAC nomenclature system, first you should identify whether the complex is cationic or anionic. Then we have to start the names. Nomenclature is very easy because you know the name of the ligands, and name of the ligands are not quite difficult. All the ligands are given in this chart. So go through this chart. Today take a printout or make a chart of these ligands and paste where we are daily in your study room. So it will be very easy for the board exam to identify, and it also shows the charges also. See, this table is very important. So prepare or take a printout of this particular page or prepare at your home. And also we will know the charges also, and what is thiocyanato and what is cyanato. Daily at least 2 minutes or 1 minute give for this table. So the nomenclature, it will be very easy. And on the nomenclature, this year they may ask the question for 2 marks or 3 marks, remember. So that's why I'm taking in detail this nomenclature system. They will give the name of the complex, or they will ask you to write the structure of the complex, or structure will be given and we have to write the name. So vice versa, they can ask the questions. Um, so all the things should be very, very clear. They can confuse you, they can give the name, or they can ask the write the structure, or they will give the structure, we have to write the name. So if you understand the rules, then it will be very easy. So again, I'm coming to this one. So see the copper oxidation state. See the oxidation state of copper is +2. I will explain how this +2 came, because the amine is neutral ligand, remember. So this 4 into 0, it will be 0, and the charge on the complex will be 2. So automatically it will be the oxidation state of the copper. Then come to the second example, FeH2O5 NCS2. So now here is NCS and SCN. So student get confused what is NCS and what is SCN. So remember, NCS is isothiocyanate, and SCN is thiocyanate, remember. In that chart also I have given. So there are two ligands alphabetically, which comes first, we have to decide first here. H2O aqua comes first. So this is a 5, means it is penta aqua. So it is written here penta aqua. Penta stands for 5 ammonia, sorry, 5 water ligands are there. 5 penta aqua isothiocyanato. See, according to the nomenclature system, rule number 2, there should not be any spacing between the name of the ligand and name of the metal. That's why the name is very, very large. That's why the name is very, very large. So don't be confused for writing the names. Though the names are very large, but it is very easy to write. Only we should understand the rules. So penta aqua. Aqua, it is a water ligand. Penta aqua. Then we have to write this second ligand. It is a isothiocyanato, because there is no any number is given here. So we are not writing how many isocyanate ligands are there. So penta aqua isothiocyanato. Remember the rule number 1. It ends with ATO, because it is isothiocyanate. It is isothiocyanato, and ion. It is not ferrate. It is ion, because the complex is cationic complexes. In case of anionic complexes, we have to change the name of the metal. It will be ferrate, it will be platinate, like this. But as the complex is cationic complexes, the name of the metal will remain same. In bracket, the oxidation state is written, and it is ion. Why it is ion? Because it is 2+. Now I am coming to the example number 3. The complex is written in the bracket, platinum En2, SCN2 and 2+. It is also the saying there are 2 different types of ligands. We have to check alphabetically which comes first. Now this ethylene diamine, but already there are 2 ethylene diamine. So the prefix bis we have to attach here, bis. Why it is bis? Because ethylene diamine already contains di. So we are not using the word again di. So it di becomes bis. So bis, ethylene diamine, the name of the ligand is written in bracket, bis ethylene diamine, and this is the di. Now comes, see the example, difference between the example number B and example number C. In this, there is no any number is written here, but in this 2 number is written, means 2 thiocyanato ligands are there. So that's why it is written here di thiocyanato. dithiocyanato, and it is a name of the metal is platinum, and 4. This 4 indicates the oxidation number of the metal. It is 4. This is oxidation number of the metal is 4. Remember. Then I will take the next examples. These are the compounds, some coordination compounds containing the complex ions and simple anion. Now see how to identify whether the complex is positively charged or negatively charged. See on the right hand side here is Br2, here is Cl, here is I3. All these Br2, Cl, I3, it will be dissociate. All these are negatively charged, Br minus, Cl minus, I minus. So automatically the charge on the complex will be positive, remember. So all these complexes are cationic complexes. These are not anionic complexes, remember. So the nomenclature system is same. First we have to write the name of the ligand. So this is the tetraamine. See, the tetraamine. In this case, don't write the names here. In case of the anionic complexes, see, if the sodium, potassium, and aluminum, sodium, potassium, these are the counter ions comes first. So we are going to write the name of the counter ions first because they they are the left hand side of the complex. But if in case of these complexes, don't start with this bromine, don't start with this chlorine or iodine. The rules are same for these complexes. We have to start from name of the ligand first. So there are 2 ligands, 2 bromine and 4 ammonia ligands are there. So there is a question alphabetically which comes first, either bromine comes first or ammonia comes first. So as the spelling indicates, amine comes first because it starts with word A. So see here in the nomenclature system, tetraamine is written because alphabetically this amine comes first. So tetraamine, then dibromo because there are 2 bromines, tetraamine dibromo, then platinum because the complex is positively charged. As the complex is positively charged, this will be remains platinum. In bracket, we have to write the oxidation state of the metal. It is oxidation state is 4. I will explain how this 4 comes. See, ammonia is a neutral ligand, so 4 into 0, it will be 0. So these 2 minus and these 2 minus, they will combine and it will be 4. So this oxidation state of the platinum is 4 because of these 2 minus and these 2 minus. Platinum 4 and bromide. This bromide is written lastly. See, this is bromide because it is outside the square bracket. It is outside the square bracket. Remember, when it is inside the square bracket, the name will be bromo. But when it is outside the square bracket, we have to write bromide. We have to write it at chloride. We have to write as iodide. Whatever outside the square bracket, we have to writing the names as it is. Bromide. Don't write here bromo, chloro again because it is a ions now, counter ions. So come to the second example. I will take these 3 examples and neutral examples because I want to start the new thing, that is effective atomic number. So I think you understand the nomenclature system. See, this is pentamine. Pentamine. This is a carbonato. This carbonate is converted into carbonato. So 5-amine carbonato, pentamine carbonato. Then the name of the metal is cobalt. In bracket 3 is oxidation number, and it is a chloride. Lastly, we have to write the chloride. Then come to this example. There are again 2 ligands. One is water and one is amine. Again, there is a question of alphabetically which comes first. This is aqua and this is amine. Both the ligands starts from A. If such type of situation is occurred when both the ligands having the same alphabet is there, then we have to take the second alphabet. So in case of amine, M is there, the second alphabet is M, and in this is Q. So Q comes later. So amine ligand comes first alphabetically. Alphabetically, this amine comes first because both the ligands starts from word A. This is amine and this is aqua, but we have to check the second letter. In case of this amine, this is a M. It comes before the Q, so it is a pentaamine. Then aqua, because there is no any number is attached here, so only single aqua is there. Pentaamine aqua. Cobalt, again name of the metal is cobalt, because see the complex we have to identify first. Complex is positively charged, so name of the metal will be cobalt. And if the name of the metal is written, automatically we have to write the name of the we have to write the oxidation number. Oxidation number is very important. If you didn't write the oxidation number, you will lose your half mark, remember. If it is asked for 1 mark, half mark will be reduced if oxidation number is wrongly written or not written. So this method is very important, how to calculate the oxidation number. So make a practice. I request, because I know by my experience of the paper checking, students make mixed mistakes here for calculating the oxidation state also, and they also make some mistakes when they are writing the name of the here name of the metal also, because the students didn't understand which complex is positively charged and which complex is negatively charged. That's why they makes a different in the name of the metal. Or many students didn't attempt such type of questions, because if they didn't attend the lecture, this is very difficult to understand. Without attending the lecture, we no any student can write the nomenclature system, remember. Some of the students are not attending the lecture, and if you ask these students, you know the nomenclature system of this coordination compound, or this is positively charged or this is negatively charged, no any student can give the names, remember. So this is my experience, that's why I'm telling you, attend the lectures carefully. So you not require any kind of personal tuition or any kind of personal guidance. So attend the lecture carefully, then we'll understand all the things I will explain at the time of lecture, which is came for board exam, which is came for CET. Now again I want to tell you some important things about this coordination compound. In JEE mains and advanced, some students are giving this exam, and also CET. 100% two questions are there from this chapter, 100%. So that's why the weightage is increased. 7 marks weightage is given this year because of these competitive exams. So the previous, in case of previous syllabus, the weightage is only 4 marks. But this year 3 marks are weightage is increased, because the importance of this coordination compound in JEE and NEET exam. Now I'm coming to this neutral complexes. So before neutral complexes, I think you understand this is a pentamine, aqua, cobalt 3 iodide. Now this is a neutral complexes. Neutral complexes means, see, there is no any charge on the complexes, and also outside the square bracket there is no any counter ion. So we can identify this complex is neutral. So in case of neutral complexes, the nomenclature system is same, but see here, as the name indicates, in case of positively charged and neutral complexes, name of the metal will not change. So it will be cobalt remains as it is, this iron remains as it is, then this is a rhodium remains, rhodium, this is the name of the metal. So it will be remains as it is. We can see clearly in the nomenclature it is written. So I will explain this example. This is a triamine, because alphabetically amines comes first before the nitro. So this is a triamine. 3 amine ligands are there. Triamine, then trinitro. See, trinitro, because there are 3 nitro ligands are there, and cobalt again, cobalt 3 in bracket. Oxidation state of the metal is written here. Then I am coming to this one is a pentacarbonyl ion, because this CO is a carbon monoxide, and nomenclature will be carbonyl. This is pentacarbonyl ion. Oxidation state is 0 here because this is a neutral ligand. And why this is a 3? Cobalt is 3 because ammonia is neutral. So this 3 minus, because of this 3 minus, it will be cobalt 3 plus. And it will be carbonyl is a neutral ligand, so it will be 0. So the charge is oxidation state of the ion is 0. Now see, this ammonia is neutral, so this is the 3 minus, SCN 3 minus. So the charge oxidation, see the oxidation state of the metal is +3 because of this SCN 3 minus. So I think the nomenclature system is completed, and this is a homework. Today's homework: write the representation of the some name of the coordination compounds are given. We have to draw the structures. So I think make a practice at your home. If you find any difficulty, call me. I will give the answers. The answers are not given here. Also, one question is one homework is given, but in this I have given the answers also. So this is for practice purpose. Write the formulas for the following coordination compounds. This is not from your textbook. Remember, I have not taken this exercise from your textbook. This is taken for your practice from the different textbooks. So we will try the first example, tetraamine. I will explain the first example. Remaining examples you can solve at your home. So at the name indicates it is a tetra. First read the name of the complex carefully. So what is this complex? It is a tetraamine. See, it is a tetraamine. Then it is aqua. This is chloride is there. Chlorido, because chloride is converted into chlorido, and cobalt 3 chloride. So we have to identify whether the complex is positive or negatively charged. As cobalt is there, means the name of the metal is remains as it is 100%. It will be the neutral, or it will be the positive cationic complexes because of this cobalt. See, name of the metals remains same, so the complex will be positively charged, or it will be neutral. Chloride, see this chloride 100%, it should be outside the bracket. That's why it is written. It will be right hand side, and we have to balance now. Tetraamine cobalt. So see this answer. See this answer. Cobalt, it is written in the square bracket. How many amines are there? Tetraamines. So 4 NH3s are written. Aqua, single aqua is there, single ligand, and how many? One chlorine is there, so that's why it is written inside the bracket. It is chlorine, and outside the bracket here Cl2. Now, how many Cls are there outside the square bracket? This is a very important task. So one chlorine or two chlorine, it depends upon the oxidation number. See, it depends upon the oxidation number, because the oxidation number of the cobalt is +3. See, ammonia is neutral. This ammonia is neutral ligand. Then we have to check the charge of this aqua. The charge of the aqua, how many charges are there? So again, I am coming to this table. Aqua is having which charge? We will check. See, aqua is neutral ligand. So again, this aqua is no having charge. See, in this aqua is neutral ligand, so it is not having charge. Only 1 minute is remaining, so I will take the. I will explain in fast. So make a practice at your home. So this is neutral. This is also neutral. So how the +3 oxidation state, because of these two chlorines, 2 minus, and this is 1. So it will be 3 minus. These are converted into 3 plus. So the cobalt is having +3 oxidation state. So make a practice of these remaining examples at your home, because for 3 marks the question may be asked for board exam.